The principles of sonde locating. A sonde, sometimes referred to as a beacon, is a small battery-operated transmitter that typically fits in the palm of your hand and can be inserted inside PVC pipes and traced or detected with Schonstedt's pipe and cable locator receivers or with dedicated sonde locators. In order to work, the sonde requires a battery and must be attached mechanically to a snake or long flexible cable to allow an operator to push it into the pipeline. Once the battery is inserted with the proper polarity and the lid is tight, the transmitter begins emitting an electromagnetic field of a certain standard frequency that the receiver can detect. The field expands in all directions, and once the sonde is inserted inside a PVC pipe and pushed along, that field will move with the sonde and reach above the ground surface, allowing an operator to trace it with a receiver. Sondes are often built into camera inspection systems for sewer pipes, water pipes, and other underground structures. Therefore, these inspection cameras can also be located with the same technique and the same instruments used to locate a sonde, as long as the frequency emitted by the cameras is the same frequency at which the receiver is operating. Because sondes are small and battery-operated, the signal they emit is limited. In addition, the sonde has to be pushed mechanically into the pipe by an operator. Because of this, sonde locating is usually done within relatively short distances, between 80 to 100 feet, or approximately 25 to 30 meters. Sondes are typically used to locate a blockage in a PVC pipe going from a house or building to a street or main pipe a short distance away. It is necessary to have a general idea of where the sonde might be and in what direction it is being pushed. Otherwise, locating it can be extremely difficult. As a rule, you must be within a distance of 40 to 50 feet from the sonde to be able to pick up its signal. As you can see, if the sonde is deeper, then the diameter of the proximity area on the surface is smaller. There are two steps to locate a sonde. First, you need to approach it, or get inside that 40 to 50 feet distance and make sure you're picking up a signal. Then, you can fine-tune the process to determine more accurately where the sonde is located. In order to understand the techniques for approaching and pinpointing, it is important to understand the relationship between the orientation of the receiver sensor array and the sonde. The signal detected by the sensor array is strongest, or peak, when the axis of the sonde and the axis of the sensors in the receiver are on the same plane. In this case, the field lines of the signal emitted by the sonde flow through the sensors, generating a strong signal. By contrast, the signal detected by the sensors is the weakest, or null, when the axis of the sonde and the axis of the sensors in the receiver are on perpendicular planes. In this case, the field lines of the signal emitted by the sonde are perpendicular to the sensors, generating essentially no signal or a minimal signal. To approach the sonde from a distance, it is best to work in circles while trying to determine where in the circle the signal is stronger. At that point, the sonde axis and the sensor axis are on the same plane. Keeping that orientation of the sensor, in other words, without rotating the receiver at all, move along that axis to the left and the right to determine in which direction the signal becomes stronger. Then, keep moving in that direction while the signal strength increases. When you move past the sonde location, the signal will start dropping again, giving you a general idea of the sonde's location. You can move back to find the strongest signal, and at that point, rotate the receiver 90 degrees, verifying that the signal drops significantly to a null. At this time, you can attempt to measure the depth with the receiver, but you must remember to rotate the receiver back to a coplanar position when the signal is strongest before measuring the depth. It is important to select the right size sonde for your particular project or application. A bigger sonde with bigger batteries can be detected deeper and farther, but it may be too large to get around elbows in the desired pipe. Although sondes may come in various frequencies, there are two fairly standard operating frequencies that are commonly used and work for most applications: Those frequencies are 512 Hz in the US and 640 Hz in the EU. In summary, before attempting to locate a sonde, always remember: 1. Make sure the sonde has a battery. 2. Test the sonde signal with your receiver before inserting it into a pipe. 3. Properly and securely attach the sonde to the snake or mechanical means to push it through the pipe. 4. Have a general idea of the location and direction in which the sonde will be moving once inserted in the pipe.